Hello guys. Today is the 17th of January and this is the LEETCODE POTD of the 17th January 2683 Neighbouring BITWISE XOR. Okay. In this question, what we have given? In this question, we have given a zero index array of derived length n with length which is derived by the computing the bitwise XOR of adjacent values in a binary array original of length n. And specifically we have given each index I in the range of 0 to n minus 1, and given if I is equals to n minus 1, then derive of I is equals to original of I XOR original of 0. Okay, otherwise derive of I is equals to original of I XOR original of I plus 1. Now we have determined that there exists a valid binary array original that could have formed the derive. Okay, if there exists a valid binary array from which we can derive the derived array, then we have to return true, otherwise we have to return false. And we have given that binary array is only consists 0 and 1s. Okay, so let us come to the test case. Derive is equals to 1 1 0. It is an array. Now we have to check that if an valid original array exists, so that we can find this derive array. Okay, so we have to find that derive of 0 is equals to original of 0 plus XOR original of 1, 0 of 1, then 1. Okay, for deriving 1 1 0, we know for deriving, just 1 second, wait for 1 second, I have been giving a page. Yeah, for deriving 1 1 0, we have to ensure that there is exist a 0 or 1 at the 0th place, otherwise 1st place. Because XOR of 0 and 1 and 1 and 0 is 1. So let us suppose we have take the 1 as a initially 1 as a original array, 1 as a I at I is equals to 0. Here you can see, let us take this is original, this is derived. Okay, so initially I take 1 as a as at 0th index in a original array. Okay, now let us suppose we know the property of XOR. Let us firstly understand the property of XOR. If x and XOR y is equals to z, then y is equals to z XOR x and x is equals to z XOR y. As we can say that all the three variables x, y, z can be find, all of the individual variable can be find by the XOR of two variables, another two variables. You can see that if this is initial condition, we can apply XOR both sides. So this is a condition x XOR x, y, x XOR x, x. So same, the values with same XOR is equals to 0 and 0 XOR y is y. So y is equals to z XOR x, we derive this. So these conditions we know, now we know the XOR of this and this bit is this. Okay, so XOR of original in original array, XOR of this and this is equals to this. Okay, we have given the conditions. Here we given that derive of I is equals to original of I XOR of original of I plus 1. This is, so what I am saying, original of I and original of I plus 1 gives the XOR of these both element, gives the element at the derive at I. Okay, so x, y or z, let's suppose. So we haven't until find this, because we only suppose this is the 1. Okay, so the XOR of this and this is this. So we know the property that if this is the XOR of this, so we can find the XOR of these both and directly put it here from these conditions which I explain here, that the XOR properties. Okay, so the XOR of 1 and 1 is equals to 0, so we can put it here, and the XOR of 1 and 0 is put it here. Now this is the original array form. Now we have to check that we have given that if I is equals to n minus 1, then derive of I is equals to original of I XOR of original of 0. So let us suppose we have to check this condition. So original, we have original this, so original of 0 we have 1, and original of n minus 1 we have 1. So XOR of 1 comma 1 and 1 is equals to 0. So we have already 0 in this place, so we return 0 from here. If we doesn't find the 1, if we let us suppose here is 1. Okay, then we have to check but taking 0 at initial. Okay, taking 0 as initial. So if by taking 0 as initial, if we take 0 as initial, 0 XOR 1, what comes? 1. 1 XOR 1 comes 0. So now we have to check. Let us suppose this is original. Now let us check also in this 0 XOR 0, what it comes? 0. So it is also perfect. You know, if we return true, if it is true, we are actually returning true directly from here directly. If it is not, we have to come on the taking the case initial as 0, then we have to return 0. Okay, if this both has not satisfied, both are not returning true, then we at last we have to return false. Okay, so let us come to this approach firstly, and you can see the solution, what I code. Okay, let's suppose this is, 1 second, yeah, hold on. Yeah, we have given a derived vector, you know, and we declared an variable in which we are storing the size of derived variable, and we declare an original a sample array which is the original, and initially we initialize with this 0. Okay, we are taking initially at the 0. Let's suppose we are taking 0 at all the steps on all the array. Okay, then we initially we are taking the original 0, then we continuing, then we are traversing a loop from I is equals to 1 to I is equals to 1 to n, and we are finding temp original of I minus 1, original of I minus 1 or derive I minus 1. What I mean to say, original of I minus 1, original of derive I minus 1. We are starting from here. Actually we originally saved this. Okay, original of I minus 1, original of derive I minus 1. The XOR of both these store in this. I store in the original of I. Okay, I can directly store also in, you know, just do not complicate it. Okay, yeah, let's just, okay, I commented it. Okay, now if this is done with if I done with that, at last I checking that the width of original of n minus 1, the nth minus 1 width, and the XOR of nth minus width of original and 0th width is equals to derived of n minus 1. We are returning true from directly here. We know there is exists a original array which we are deriving. Okay, if it is not true, we are taking original I as 1. So we are actually save all the in the array of original all the elements as 1, and now we taking the original 1. So in this we traverse on the same loop for I is equals to 1 to n. You can see that this is the same loop. I just copied and pasted here. Okay, and if it is equals to and if this condition is followed, which is last and first XOR of original array is equals to derive of n minus 1, last value of derive, and we are returning true. If it is not, at last we have to return false. We this condition states that there is no original array exist for the derive. Okay, let's just run this code. Now you can see that it is that all test cases passed, and this submit code, and this is also submitted. Okay, just submitted. Yeah, you can see that. Okay, now this is not the most optimized approach. Let's come to the most optimized approach. Just 1 minute. Yeah, now you're seeing that we are what actually doing that we are actually what is doing that in the original array what it comes at the place, it comes that a XOR v, you know, a XOR b, a, let's suppose it is a b c. So all the occurrence, all the let's suppose this is a, this is e, this is b c. Yeah, you can say that this is the a, this is b, this is c. I know. So what are happening here? Happening here is that if we make the XOR of a and b, it comes let's suppose a b c. This is a XOR b comes here. Okay, v XOR c comes here, and c XOR a comes here. So we are seeing that all the a b c are occurring 2 times. So we are if we are seeing that if we make XOR of all the elements, it is 0. So we have find the clue that if in the or if in the derived array which we are given, okay, if in this XOR of all the elements is 0, then it is always true. Okay, then it is always true that a valid array exists. If it isn't, then it is always that it have not exist in a derived array. So you can see that the I have stored this is the most optimized approach which we can think. I stored a answer in 0 and I traverse a loop for a derive and just nums and just takes a bitwise XOR of all the elements in answer variable, and if answer variable is now 0, I am just returning true, otherwise it returns false. Okay, let's just submit this code, and it's the most optimized approach which you can think about the solution. Okay, let's just submit the code. Yeah, you can see that it is passed and it is 100% optimized. Okay, let's just suppose if you like the code and the way of explaining me and the content in the code, then you can like the video and comment the what you part you can like the video, which part of the video you can like, and just motivate me by commenting and like the video. Thanks.